Alright, solving this circuit, first thing I gotta do is combine those two resistors in series, resistors 2 and 3 in series. If I could just replace those with a single resistor 2, 3, and resistor 2, 3 would be resistor 2 plus resistor 3 because they are in series with each other. That's 910,000 plus 870,000, which is, let's see, 910 plus 870 is that many thousands, 1780. So that would be 1.78 mega ohms. 1.78 mega ohms. That might be a little easier to write down. Now, I want to keep that number in mind, so I'm going to write that down here. Resistor 2 and 3 combines to be 1.78 mega ohms. All right, now then, these two are in parallel with each other, and so they're going to combine a little bit differently. So the combination here is going to be equal to 1 over this resistor plus 1 over that resistor. So that's going to be a whole lot. This is 1.78. I'm going to save myself a little bit of math headache from scientific notation. If I did 1 over 1.78, I'd have 0.5618. And if I did 1 over 2.2, I'd have 0.4545. So if I were to add those together, 618, I'd have 1.016. Now, if 1.016 is 1 over the total resistance, then I just need to flip this, and it is 0.9839. Now, because the answer is 0.9839, this whole time this was in mega ohms, that's the little bit of trouble I was saving myself in scientific notation. So if this is 0.9839 mega ohms, then I can replace these conceptually anyway with a single resistor that is 0.9839 mega ohms. It's only going to be there for a second, so I'm not going to bother naming it because it's in series with resistor 1, and that makes the whole circuit. So if we add those together, we get 2.084. So that would be the total resistance for this whole circuit. 2.084 mega ohms. Okay, so now is about time that we would redraw the circuit as it was. Okay then, so let's see how much of the circuit each resistor is, just setting up these proportions. 1.1 mega ohms out of 2.084 mega ohms. Let's see, 1.1 out of 2.084. I've got 0.5278. So I'm just going to call it 52.8% of the circuit. Now, these two branches are going to get the same voltage, namely, be the rest of it. So if I just did the difference, I'd have 47.2%. But what's funny is These two, we're going to have to split that. So let me actually do this calculations real quick. What is 52.8% of 11.6? 52.8% of 11.6 is 6.125 if we round it. I think that it's time that I write a few numbers in this here. So resistor 1 has a resistance of 1.1 mega ohms, and it has 6.125 volts across it. Now, I'm going to skip resistors 2 and 3 for a second. I'm going to go straight to resistor 4. Resistor 4 has 47.2%. That would be 0.472. It's 47.2% times 11.6. That's 5.475 volts. 5.475. And they should add up. Meaning these two should add up to that. So if I write that down for resistor 4, resistor 4 is 2.2 mega amps. I'm sorry, mega ohms, and 5.475. What's funny is this voltage must also be there, but they share it. So how much of this branch does each of them take up? This is 910 and 870. Remember, I said I would need this, so they add up to 1.78 million. So 0.91 out of 1.78, 51.1%. That's 51.1% of this little branch here. And this one, that'll be 0.87 divided by 1.78, and I've got 48.9%. Yep, that adds up to 100%. So that's going to be the percentage of 5.475 volts that they must share. So what is 51.1% of 5.475? It's 2.798. What is 48.9% of 5.475? It is 2.677. So those are the voltages across those two resistors. So resistor 2 has a resistance of 910 kiloohms, and it has a voltage of 2.798 volts. Resistor 3 has a resistance of 870 kiloohms, and there are 2.677 volts across it. All right, well, all that's essentially done, because everything can be calculated from V and from R. For example, according to Ohm's law, current is equal to voltage divided by resistance. So here I can do 6.125 divided by 1,100,000. Okay, so I'm going to be putting this in scientific notation. That's 5.568 times 10 to the negative 6 amps. Not a lot. Not a lot. Okay. 2.798 divided by 910,000 is 3.074 times 10 to the, I see 5 zeros, so that's 10 to the negative 6 again. Amps. 2.677 divided by 870,000. Okay, 3.077 times 10 to the negative 6. These two should basically be the same because they're in series. The last one, resistor 4, I can see 5.475 volts divided by 2,200,000. And that is 50, so that's 2.488 times 10 to the negative 6 amps. The last one, P, according to Joule's law, P is equal to IV. So all you need to do is multiply those. So let me go ahead and do that. 6.125 times 5.568. So 34, got to remember that 10 to the negative 6. So I've got 3.410 times 10 to the negative 5th watts. 3.074 times 2.798. I've got 8.601 times 10 to the negative 6 watts. Two more, 3.077 times 2.677. That's 8.237 times 10 to the negative 6 watts. Last one, and then we're done. 2.488 times 5.475. Oh, it's 2 digits, so I'm going to have to take one away. 1.362 times 10 to the negative 5th watts. Have a look. There you go.